Algebra 2, Lesson 121, Rational Inequalities. So, rational inequalities are inequalities with fractions. Right? And these can show up in a couple of different varieties. Let's just go straight to our practice. Okay, so here's our first example. We've got 1 is less than or equal to negative 1 over x minus 4, with the domain being reals. So just like any of our fractional equations, the first thing we want to do, if we want to get rid of this denominator, the way we're going to do that, we're going to multiply each side by the denominator. So if I multiply this side by x minus 4 and this side by x minus 4, that fraction is going to go away. But I have to distribute on the left side now. So now 1 times x, 1 minus, oh hey, that's pretty simple. I end up with x minus 4 less than and equal to negative 1. And our last step, I'm just going to move the 4 over here. And now I've got x less than and equal to 3. Now, that's pretty, that's pretty, what's the word for this? Pretty logical. That's what we're used to, right? What makes it not simple is one of the key things of algebra that we have to remember. So normally if this were an equation, what we just did would have been perfect and fine and absolutely right, but it's not an equation, it's an inequality. And if you remember, whenever we have inequalities, if we multiply or divide by a negative number, we then have to reverse the sign, right? So the problem is the variable x, I don't know if x is positive or negative. I don't know if I have to reverse the sign or not. So that's where the problem shows up. So that's why I can't quite do it this simply, okay? But what I do know is that if I squared x, if I square this term, it doesn't matter if x is positive or negative. When it squares, it's going to become positive anyway. So if I multiply by the denominator squared, or the variable squared, I can eliminate that problem of negatives. So that's what we actually have to do. So let's go back, let's go over here into the land of alternate realities, right? And we're going to redo this problem the right way, okay? So I kind of did that way to kind of explain why we're not doing the x squared, because if I just said we had to multiply by x minus 4 squared right off the bat, people would have been confused. So for those of you who are frustrated, like, Mr. Clear, why'd you even show me the wrong way? Well, it's because if I just showed you the right way at first, you'd still be confused anyway. So let's get on with it. We've got 1 less than or equal to negative 1 over x minus 4. And now that I've got that new knowledge of negatives being squared, I'm going to now multiply each side by the denominator squared, right? And so that changes my answer a little bit. What's going to happen here on the left side is this one will cancel and the exponent will cancel. So now I've got one number to distribute, okay? Now the left side is going to be a little bit more complicated because I have to FOIL x minus 4 before I distribute the 1. So once I FOIL that, I end up with x squared minus 8x and plus 16. Okay? And that completely cancels out any negative issues that I would have had. So now I've got x squared minus 8x plus 16. The 1 distributes and makes that the same, no change when I multiply by 1. And then here, the negative 1 is going to give me negative 1x plus 4. Okay? I'm just going to do a quick check, make sure I'm not missing anything. Yep, we're still good to go. Okay? Now from here, I have to get all the x's on one side and then solve, or actually what I'm going to do is I'm going to solve everything equal to 0. I'm going to use zero factor theorem. So let's add 1x minus 4. Okay, so the right side of the equation is now going to be 0. The left side of the equation, 16 minus 4, is going to be 12. Negative 8x plus 1x is negative 7x, and then x squared stays the same. So now I've got a quadratic, it's set equal to 0. I'm going to use zero factor theorem to solve. So let's factor this. X is x. If that's positive, that's the same as negative, so it's going to be minus minus. What times what equals 12 but adds up to 7? That's 3 and 4. 3 times 4 is 12, adds up to 7. So if x minus 3 and x minus 4 is greater than or equal to 0, that means for my inequality, I'm going to go to the opposite. So using zero factor theorem, it's going to be positive 3, positive 4. So over here, I'm going to go to 3 and 4. That's 3 and 4. And then I put a solid dot at 3. And I'm going to go put a conjunction, since this is a less than symbol, put a conjunction, and then we'll have a solid dot at 4. Whoa, wait, solid. No, they have an open dot. Did I do something wrong? Okay, I just found it. Sorry, I didn't realize, I thought I pressed the pause button while I was reading this to figure out where the mistake was. All right, so the reason why it's open circle at 4 is because if we go back to the original problem, there's a domain issue, right? If x were equal to 4, 4 minus 4 would be 0. So I missed that in the very beginning. So remember, if you have fractions, we got to eliminate any domain issues. So normally it would have been a solid dot at 4, but in this case it's actually an open dot at 4. Okay, great. Now that we got that figured out, let's see here. What is next? All right, we got to do another version of this problem. Okay. So this one we've got m minus 2 over m plus 2 is less than or equal to 2. Similar setup of the problem, except now we got a variable in the numerator too. I'm gonna have to multiply this. Actually, I got to rewrite this. I took up all my room down here. So let's put down m minus 2 over m plus 2. Less than equal to 2. We're going to multiply both sides by m plus 2 squared because that's the denominator. M plus 2 squared, and so I don't make the mistake that I made before because of zero factor theorem. M cannot be negative 2 because that would make the denominator 0, so I'm going to remember that in case I run into that later. And then over here we multiply by m plus 2 squared. The right side, what happens, or sorry, the left side, this cancels with the exponent, so now I have m plus 2 times m minus 2. Hey, that's a difference of 2 squares. That's going to be an easy multiplication. So that gives me m squared minus 4, less than and equal to 2 times m plus 2 squared. So m plus 2 squared is going to become m squared plus 4, and then that would be plus 4m in the middle. So 2 times that is going to make it 2m squared plus 8m plus 8. Great. So now I've finished rewriting the problem. I've noted the domain issues, and I've solved the negative issue as far as inequalities go. Now I just need to get the equation all on one side of the inequality and then solve. All right. Oh, yeah. If you guys are seeing, ignore that. Okay. This is a piece of scratch paper, okay? Just ignore that messed up printed ad. Let's see here. Right. Setting this equal to 0. I'm just going to move everything to the right side. That'll be easier. So I'll add 4 minus m squared minus m squared. When I do all that, I've got 0 less than equal to, let's see here, 2m squared minus m squared is just m squared plus 8m. And then plus 12. Cool. Now I'll factor this. I've got m and m. Positive same, so it's plus plus. What times what equals 12? That adds up to 8. That's 2 and 6. 2 can't be equal to 2. Can't be equal to negative 2. So zero factor theorem is going to tell me that we're going to have 2 is less than or equal to, negative 2 less than or equal to m. Negative 6 less than or equal to m. I can get rid of that equal to, and then let's just go ahead and graph this conjunction. Oh wait, whoops, I gotta test this out. Is it possible for m to be greater than negative 2 and greater than negative 6? Not quite, but what if it was less than and greater than? Oh wait, sorry. I should use my rule. So normally my rule is if it's less than, it's going to be a conjunction. However, this one's written backwards. So if I were to flip it, to the other side, it would actually be written as m is greater than -2, m is greater than or equal to -6. So it's written a little bit backwards. So now I can see greater than, this is going to be a disjunction. So I'll go ahead and do the disjunction. We've got -2, whoops, -6, -2, open circle at -2 because of that domain error, close circle at -6, arrow going to the left. All right. Whew, that's it for this lesson. Sorry for all the struggles. Hopefully you guys made it through with me, including that little brief period of silence. If you have any questions, let me know on the school website, and I will see you in class.